Hello class, this is Mr. Hart, and in this podcast we want to continue our discussion of coordinate geometry. In the last podcast we talked about how we can use the distance formula to find some specific values and some things about the shapes in the coordinate plane. In this podcast we're going to look at the slope formula. So let's remind ourselves that the slope formula is given by that the slope m is equal to the y2 minus y1 over x2 minus x1. Okay. So the value for the slope is the y value of the second point minus the y value of the first point over the x value of the second point minus the x value of the first point. Okay, so hopefully this is review. Let's go ahead and try an example problem with this one. Okay, so find the slope between the point 2 comma negative 5 and negative 3 comma negative 8. Okay, so we're just going to take that the slope is equal to our formula y2 minus y1 over x2 minus x1. So in this case, this is going to be x2, this is going to be y2, this is going to be x1, this is going to be y1. Okay, and we can just plug them straight into the formula. Okay, so y2 in this case is negative 8, y1 is negative 5, or plus a positive 5, minusing a negative is the same as adding a positive. Okay, over x2, which is negative 3, minus x1, which is 2. Okay, so we just simplify the top. Negative 8 plus 5 is going to give us a negative 3. Negative 3 minus 2 is going to give us a negative 5. And we just simplify that out. We get a negative over a negative becomes a positive, so we get 3/5. Okay, so that's the slope between those 2 points. Okay. Let's look at what this actually looks like in the coordinate plane. So if we're looking at this in the coordinate plane, we have the 2 points, 2 comma negative 5, which is 1, 2 over, 1, 2, 3, 4, 5 down, right here, and negative 3 comma negative 8 over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when we found the slope, we found that m value. What we're finding is the slope of that line between those 2 points, okay? And so we found that m was equal to 3/5, and we can double check that that makes sense, right? If that's the case, then it should go over 5 every time it goes up 3, right? Over 1, 2, 3, 4, 5, up 1, 2, 3. There you go. 5, rise 3, run 5, right? So that's the slope of that line. Okay, so when we're using that formula, we're just finding the slope of the line that connects those 2 points. So let's see an example of when we can use this. We're going to apply this to determining if we have right triangles in the coordinate plane and determining if we have parallelograms in the coordinate plane. Okay, so let's start with right triangles. So when we're working with right triangles, we know that we have at least one right angle. Okay. This means that the 2 sides of the triangle are perpendicular to each other. So if you look over here, right, we have this right angle on the triangle. This line from E to F and that line from E to G are perpendicular. Okay. Well, if we think about that in terms of slope, then we know that that means they are opposite reciprocals. Okay. So right angles are made of lines with opposite and reciprocal slopes. Okay. What does that mean? Okay. Hopefully you learned this in a previous class, but if you have some value a for the slope, then the opposite reciprocal of that is going to be negative 1 over that value. Okay, opposite meaning negative, reciprocal meaning 1 over that. Okay, so if I find the slope of some value a, then negative 1 over a is its opposite reciprocal. So if we have a triangle in the coordinate plane and we find the 2 slopes, or the slope of the 3 different sides of that triangle, then 2 of them need to be opposite reciprocals. Okay, that's when we have a right triangle. Okay, so we find the slopes of all 3 lines, all 3 sides of that triangle. If 2 of them are opposite reciprocals, then we have a right triangle. So let's look at an example problem. Okay, let's say you have this question: is the triangle formed by the points 1, 2, 7, 2, and 4, 5 a right triangle? Okay, so all we have to do is find the slope of each side formed by the points and determine if any are opposite reciprocals. Okay, so again, we're going to kind of split this up into 3 different sections for each different side. So we're going to say m is equal to the side between these 2 points. We're going to find the m for the side between these 2 points, and we're going to find this m for this point and that point. Okay, so let's look at the side formed by 1, 2, and 7, 2. Okay, so we know that the formula is y2 minus y1 over x2 minus x1. Okay, in this case, this is our second point, so y2 is going to be 2. y1 is also going to be 2. x2 is going to be 7. And x1 is going to be 1. So what is that going to give us? That's going to give us 0 on top and 6 on the bottom. 0 over 6 is just the same as 0. Okay, so the slope for the first line is just a flat line, okay, because it's 0. Okay, 0 slope. Okay, let's try it for the next one. So we got y2 minus y1 over x2 minus x1. Okay, in this case, we're doing this point and that point, so y2 is going to be 5. y1 is going to be 2 over x2 is going to be 4, and x1 is going to be 7. Okay, so that's going to give us a positive 3 on top, and 4 minus 7 is going to give us a negative 3 on bottom. 3 over negative 3, if we simplify that, it's just going to give us a negative 1 over 1, or just a negative 1. Okay, so negative 1 is our slope on this line. Okay, so we need to have an opposite reciprocal slope of that, so it either has to be positive infinity to be opposite reciprocal of 0, okay, or it needs to be positive 1 to be opposite reciprocal of negative 1. Okay, let's see what we get. So same formula, y2 minus y1 over x2 minus x1. So in this case, we're comparing this point right here to that point right there. Let's call this the second point and this the first point. Okay, so in this case, y2 is 2, y1 is 5, and let's see, x2 is 1, and x1 is 4. Okay, that's going to give us a 2 minus 5, which is negative 3. 1 minus 4 is also negative 3. When we simplify that out, negative 3 over negative 3 is the same as a 1 over 1, or just 1. Okay, so now negative 1 and 1 are opposite reciprocals of each other. Okay, they form a perpendicular intersection. Okay, so that means we have a right triangle in this case, okay, because they are opposite reciprocals. Because you could also think of it like this: negative 1, if that was A, then negative 1 over A is positive 1, okay, so that means they are opposite reciprocals. Okay, so that's what you're doing for these types of problems. You find all the slopes. If any are opposite reciprocals, then you have a right triangle, okay, like in this example. Okay, let's move on to our other application, and that is with parallelograms. Okay, so parallelograms are four-sided figures in which opposite sides are parallel. Okay, so if you look at this picture, we have, it kind of looks like a rectangle, not quite, it's kind of skewed to a side, right? But the key here is that we have parallel lines here and parallel lines there, right? AB is parallel to DC, and BC is parallel to AD. Okay, so you have this relation between the sides where opposite sides are parallel. Okay, so when we're dealing with parallelograms and trying to see if we have a parallelogram in the coordinate plane, what we do is we find the slopes of all four sides of the parallelogram, and if these sides opposite each other have the same slopes, then the figure is parallel. Okay, so if this slope matches that slope and this slope matches that slope, then we have a parallelogram. Okay, so let's try an example problem. So we're trying to determine if the points 0, 1, 1, 3, 5, 4, and 4, 2 form a parallelogram. Okay, and so you can kind of think of the parallelogram in the previous picture. We're trying to see if those sides are parallel. Okay, so what we do in this case is we need actually 4 different slopes. Okay, one for each point. I'll try and write small so we can fit it all on this page. Okay, so we'll do A to B, B to C, C to D, and D back to A. Okay, so the slope for A to B is going to be y2 minus y1. Okay, so y2 is going to be 3, y1 is going to be 1, x2 is going to be 1, and x1 is going to be 0. Okay, that's going to give us a 2 on top, a 1 on the bottom, which is going to give us 2. Okay, now let's find the slope from B to C. Okay, so C is going to give us the second point, so y2 is going to be 4 in this case, y1 is going to be 3, x2 is going to be 5, and x1 is going to be 1. So the slope for this case is 1 over 4. Okay, so if this is a parallelogram, the opposite sides are going to have to match, which means the next slope better equal 2, and the slope after that better equal 1/4. If that doesn't happen, then we don't have a parallelogram. Okay, but let's see. Okay, so now we're comparing C to D. So y2 in this case is going to be 2. Y1 is going to be 4. X2 is going to be 4 as well, and x1 is going to be 5. Okay, so negative 2 on the top, 2 minus 4 is negative 2. 4 minus 5 on the bottom is going to give us negative 1. That's going to equal 2. Okay, good. We're good so far. That 2 and that 2 match up, so these sides are parallel. Let's check on the last side. So M equals, now we're doing D to A. So A is going to be our second point, D is going to be our first point. So that y2 is going to be 1, y1 is going to be 2, x2 is going to be 0, x1 is going to be 4. Okay, so that's going to give us 1 minus 2 is negative 1 on the top, 0 minus 4 is negative 4. That's going to give us a 1/4. Okay, there we go. So that 1/4 matches up with that 1/4. Okay, so we're good there. Those sides are opposite, or sorry, those sides are parallel, and that 2 matches up with that 2, so those sides are parallel. Okay, so this is, yes, a parallelogram, okay, because opposite sides have the same slope. Okay, so that's your homework. You're going to find right triangles in the coordinate plane, and you're going to find parallelograms in the coordinate plane. Okay, hopefully this all makes sense. Let me know if you have any questions, and thank you for watching.